Now we are continuing with the uh, true experimental design. The elements of true experimental design include manipulation or intervention, control, and randomization. So, as I mentioned before in the previous class, the true experimental design is considered as the strongest design where the cause and effect relationship is established with 100% confidence. That means with 100% surety we can say that this effect has occurred only because of this particular cause. Now take for example, in Mahabharata there was a character called Kijagan. Now who killed Kijaga? I mean, the question is only one answer, because this if for this particular effect the only cause is Bhima. There is no other persons in the universe can kill Kijaga. So that is with 100% surety can say that if for the death of Kijagan the cause is the power of Bhima. So this is the surety. With 100% surety we are able to tell that this particular effect has occurred because of this cause only. That is the surety of true experimental design. That is the strength of true experimental design. That is why we call it as a true experimental design, because we know that the researcher has 100% control over the independent variable. Without the knowledge of the researcher, nothing will happen to the independent variable. And if some changes has occurred in the dependent variable, that is only because of the change given by the researcher over the independent variable. So all these things are measured. So again, when we hear the term experimental design, we always think about laboratories, lot of chemicals, test tubes, burners, beaker, etc. I mean, that is an experiment for us. That is what it's called as an experiment. But we can do an experimental study without a laboratory also. Can conduct an experimental study in the hospital situation, in the community, or in any place if we have three elements in that particular study. So these elements are called the elements of true experimental study. These are the manipulation or intervention, control, and randomization. So these are the three elements of experimental design. Now we'll see one by one what is this elements. First we'll see randomization. What is randomization? Randomization means this is the random allocation of subjects into the experimental group and into the control group. So without any subjectivity, by objective methods, a researcher or the investigator allowed some of the subjects into experimental group and some into the control group. That's we call as a randomization. For that we have several methods called lottery methods, tossing a coin, random table method, and matching. And again, before that we have control and manipulation or interventions. Now what do you mean by a manipulation or intervention? Whenever we hear the term manipulation, I mean, that is has a bad meaning in our mind, especially because of the films and all. Are a great manipulator. I mean, that's a term we have heard. But manipulation simply means an intervention done by the researcher. Now, what is this intervention? This is an essential element of a true experimental study, and this intervention is needed for all type of experiment. Even the quasi experiment intervention is there. Even in the pre-experiment also intervention is there. The intervention is a common element in all these type of three forms of study. If no intervention, we call that as a non-experimental study. So manipulation or intervention is an essential element. So what do you mean by a manipulation or intervention? So this is a measured change given by the researcher on the independent variable. That's we call as intervention. Sometimes it not always measure changing the independent variable. For example, if you have developed a new drug, you want to test the effect of that drug in changing the hemoglobin of antenatal mothers. So that drug is intervention. And some group you are giving a drug, and some group you may give a placebo also, that I will discuss along the control. And you have developed a beautiful standardized teaching plan, teaching module to improve the knowledge, attitude and practice of mothers related to balanced diet of under 5 children. So this teaching module is again an intervention, because you want to change the knowledge of mothers. So that is an independent variable there. And or a room temperature is there. You want to see the effect of changing room temperature on the learning effectiveness of students. So the room temperature you are changing. So that change given by the researcher, we call it as an intervention. For example, at 20 degrees Celsius, making the room temperature, that is an independent variable, in 20 degrees Celsius, and see how effectively they are learning, the readiness to learn. And you are making the temperature to 25, then to 30, and then to 35, then to 40, 45 and 50, and you are measuring the readiness of learning or effectiveness of learning in this temperature. So this is the intervention. This is a measured, priorly designed intervention, design changes. So when you are giving an intervention, we have to define who will give intervention, what is the intervention, what is the amount of intervention, at what time we will give intervention, at what interval we will give intervention, what is the quantity and quality of intervention, what is the expected change due to intervention, and how we are going to measure this intervention. Okay, so all these things should be defined. Then only that becomes a true experiment. Okay, this is about manipulation or intervention. Now next is a control. What is a control means? There are two types of control in true experimental design. The first one, there are two groups. One is the experimental group, another one is a control group. There are two groups are there. So experimental group means that is in that group really the intervention is done, and control group is the standard group. And finally we measure the changes in the experimental group with the control group. I'll give you an example. There are 50 students in the classroom. we divide them into 25 and 25, and 25 we are making it as a control. Okay, we are not giving say a teaching module to change the knowledge about the COVID-19. We have developed a beautiful teaching module. The 25 students we are sending to the library or to home, no teaching, and another 25 we are giving teaching. And before teaching we measure the knowledge, attitude and practice of both the group, and after teaching also we measure the experimental group, is there any change in the knowledge, attitude and practice, and the control group also we will measure without giving teaching, knowledge, attitude and practice, and we will see is there any difference between. We expect the same reading in the pre and post in the control group because no intervention is done, but we expect a big change in the knowledge, attitude and practice, the pre and the post in the experimental group because we are given a teaching. So the effectiveness we are able to determine only by comparing with the control group. So we need two groups, experimental group and the control group. And the second form of control in the true experimental study is the amount of control exerted by the researcher over the independent variable. How effectively they are controlling independent variable and how effectively they are controlling the extraneous variable, external variable that we are not studying, but at the same time that may affect independent variable. For example, in a classroom, when we change the temperature, along with so many other factors are there. For example, the noise from outside, ventilation, lighting, so many factors, and we should see that the whole research study you have to make all these things are constant, same ventilation, same lighting, same noise level, absence of noise throughout all this measurement. That is the controlling extraneous variable. So this is control. Then randomization, as I mentioned before, is a random allocation of subjects into experimental and control group. Now we have to, without any bias, without any subjectivity, we should allocate to subjects into experimental group and a control group. Then only that becomes a true experiment. Randomization is random allocation without any prejudice, without any bias, by following all the scientific nature. Randomly we have to allocate subject into experimental group and control group, and there are several methods are there for this random allocation. As I mentioned before, there are several methods are there for random allocation. How we can allot? These are some of the methods. One is a lottery method. What is lottery method is, how we'll take the lottery. For example, if there are 50 students are there, we want to send 1 or 2 students for attending the marriage function of a teacher. So we write all the names of 50 and randomly we select 1 or 2 from the 50. So who will get the lottery? They will go. So this is a lottery method. This is how we'll take the lottery also. From millions of tickets sold, we select 1. First we'll select actually the districts. From the district, the locality, and from there we'll select 1 person as the luckiest person. We'll get the lottery. So the same method will follow. It's a scientific method because equal chance is given to all the person to become the first, and all the 50 in the classroom has equal chance to attend the marriage, isn't it? So the equal chance is given, that is randomization for all the subjects to enter into the experimental group or to the control group. The equal chance is there, but because of they are getting the lottery, few will enter into the experiment group, few will enter into the control group, but allocation is random, equal chance is there. So that is a lottery method. Then another thing called the tossing a coin method. For example, in a study, you are sitting in the OP. Those patients who are coming to the OP, you want to allocate them into either to the experimental method or to the control group. So whenever they come, you just toss a coin. We fix priorly. If the head comes, they will go to the experiment group. If the tail comes, they go to the control group. So this is tossing a coin. That is also by chance. They are going to either to the experiment group or to the control group. So this is also a scientific method, because you know that before starting the cricket match, who will get the batting is determined by tossing a coin. Who will get the head? They can decide whether they want batting or bowling. So similarly, so this is a scientific method where we randomly allocate a subject to either to the experimental group or to the control group by tossing a coin. Then in some studies, even we use how they turn into an OP studies and how they turn. For example, the person who comes first, the investigator have no idea who will come first. First will go to the experimental group, and who comes second will go to the control group. By chance, they are allocating. There is no bias. We are not seeing whether that person is a very good intelligent student, so that we will select them to experimental group and give teaching. No, that is not possible, because otherwise the study can become biased. All the intelligent people will select into the experimental group, and all non-intelligent students to the control group, and will teaching and will get a very good result. Teaching is very, very effective because all experiment group consists of highly intelligent students. So that is not possible. So that's in order to avoid this bias only, we are doing a randomization. Then the most scientific method is a random table method. Random table is a table prepared by computer. In the +2 classes, you have seen the logarithmic table. Logarithmic table is there. This table is also prepared in the similar way like a logarithmic table. And even the statistic textbook, in the last page you can see a random table. These are the numbers randomly allocated by a mechanical device, usually computer, and the numbers are arranged. And you just open the random table and close your eyes and allow a pencil to fall on some number. So without any prejudice, you are selecting a number, and from that point either you can travel the number, you can select the number on the right side or left side or top or bottom, but after that you have to follow systematically the number following this. So whichever the number is coming, you are selecting into the experimental group or to the control group. So this is the random table method. The random table method is an ideal method for randomization. Then matching, there is a term called matching. Matching means when we select a subject to the experimental group, we will wait for another person with the same characteristics to allocate to the control group. For example, an antenatal mother is coming with degree education, maybe 5 feet height, with 10 gram percentage hemoglobin level, with maybe monthly income of 20,000, and we choose an exact match with all the same characteristics to the control group. So that's we call as a matching. So matching is a very tedious process, and sometimes it becomes unscientific also, because we have to select the exact matches, and sometimes a lot of biases also will occur while selecting exact matches. So this is some of the problems with the matching. So these are the methods of randomization: lottery method, tossing a coin, random table method, and matching. So in the true experimental design, what we have discussed is there are three important elements are there for experimental design. If all these three elements are there without any laboratory investigations, laboratory tests, we call that study as true experimental design. The elements are the intervention or manipulation, control, there's a control group, and the control over variables, and randomization. The randomization, we have four important methods for randomizing: lottery method, tossing a coin, random table method, and matching. And the next class we will discuss about the important designs in the experimental designs. In the experimental design also is a term. Under that, there are so many type of designs are there. Again, we know that we started from an approach called quantitative approach. From there, we have quantitative designs. There are three types of designs: quantitative design, qualitative design, and mixed design. Under the quantitative design, we have several designs called true experiment, quasi-experiment, pre-experiment, and non-experiment. Under true experiment, we have seen the characteristics. Under true experiment, there are still further designs are there. So that designs we'll discuss in the next class.